Right. So good afternoon to everyone, to the geographers who have managed to join us. I know a lot of teachers are back at school and it's a little bit crazy and hectic, so we do appreciate your time and that you're joining us. We can't believe it's in September already. Eventually the weather got the memo and it's now spring. And it was certainly not feeling like spring on spring day. But anyway, just a reminder quickly, please, when we do have our webinar, that we ask you to please stay muted while the presenters are speaking, and to please put a question in the chat, whether you ask it aloud or not, because we keep a record of those questions and we're able to refer to them later again. We aren't sure how good your streaming is today. It was going to be load shedding in places. It's probably not, but if you're struggling with streaming or hearing, please keep your video off. And thank you for joining us. Please become a SAGTA member if you aren't one. And you can email Amanda, the secretary at sagta.org.za. So very excited that we can grow this family. We have had a huge number of registrations recently, which we're excited about. And I think it's important that you as geography teachers are able to benefit from each other. So the agenda for today, we have just a reminder where you'll find all this information from today, and then a few other things, and we'll get to the SANSA presentation, okay, which is the exciting one. Just a reminder, the SAGTA website, which looks like this. If you scroll slightly down where you find your topo map and orthophoto map downloader, you will see the online teaching resources. If you click on that, it takes you to a shared Google Drive, and under webinars, you must click on webinars, please. Webinar 5, we've got the SANSA information if you want to go and find it there. And on this document, as soon as it's available, you'll be able to also watch the recording of today. So you'll be able to find it over here, as well as the previous webinars information. If you scroll slightly down from there, you'll find how to apply for SAGTA membership. I have had quite a few queries regarding that. Please click on either one which works for you, and the options for payments are also on these documents. Okay, so that's where you're going to find today's information as well. Right, Pam, over to you quickly.
I am doing a last promo for SANGO 2020, which is taking place on the 15th of September. That's next Tuesday. So it can be done anytime between 7 a.m. and 5 p.m. under exam conditions or control conditions, and you have 2 hours in which to complete it, or the learner has 2 hours. So if there's still schools who are wishing to participate, on the left-hand side of the screen, you need to submit your expression of interest, get your learners to sign up tomorrow, and then by, I think it's Friday the 11th, or Thursday's the 11th? Thursday. 8th, 9th. Yeah, Friday, you need to have paid the school registration fee, and you will get all the logins and everything else. So just a little bit about this year's SANGO, because I think it's quite important. The focus is a regional focus on the Eurasian continental divide. So Eurasia geography is what you need to be looking at. And this year, the Royal Geographical Society is endorsing the SANGO.
I will close my door. Okay.
And because they are kind of sponsoring us now, there is an extra question at the end. The participants don't need to participate, but I can assure you it's a fun-filled question section, and I think they will enjoy it very much. And it's on Antarctic continent and the 2019 Weddell Sea expedition, which is obviously an expedition to Antarctica. And seeing it's just down south from us, why don't we get to learn a bit more? So we really hope that you will encourage your learners, and if you're not sure to join, please join us this year. by 2024, we're hoping to participate in the first IGU, so it's the International Geography Union Olympiad. So we really are hoping to really build up our resources, build up our learners so that we can actually participate in that event in 2024. So that's my Sango bit.
Okay, Pam, are you going to speak about the
No, I
webinar?
think you can,
Okay.
Inika, you can speak to that.
All right, thank you, Pam. So we have a really exciting webinar. It's a little bit of an advance warning so that you can plan your diaries, please. And the matrics are gone by then, so maybe you have some more time. But we got a very, very fascinating webinar planned for the 22nd of October on problem-based learning, which is pretty much the buzzword at the moment. And we have the Northwest University Associate Professor Aubrey Golightly, who will be speaking on this. And he's going to look at these topics and the points over here that you can see on the screen. I really think if we're moving into a whole new normal, this is definitely something you don't want to miss, especially for your planning for 2021. So please just diarize 22 October. It's already planned and booked. And we would like as many geographers as possible listening in so we can do a better job in the classroom. Right, and then this is Pam again.
Right, so in August, Bridget and I represented SAGTA at the SANSA Science Fest webinar or sort of virtual conference. And I used the analogy that geography is actually a science. Everybody thinks geography is not a science. We know geography is life. And I was challenging Dan, and that's why Dan and Santa are with us today, is why geography is not promoted as one of these sort of umbrella sciences. So if you look at the little logo that I sort of developed after that conference, you will see that there are various aspects. We're really an umbrella subject, and there's quite a lot of science in it. Not pure science, but there could be environmental science, earth science. So the geospatial science is what we're interested in today, and is what SANSA is going to be sort of talking to us about, telling us about the very many opportunities. So we have Dan, Johnny, and Sino Sipo. Sino Sipo is an intern now with SANSA, but I'm going to let Dan explain that. And she's actually put together the presentation. She's from the Eastern Cape, and I trust that she has managed to persuade some teachers from the Eastern Cape to join us today as well. So I'm not going to say much more, but I do think we need space science back in geography. Some of us still do it, but if we could be teaching a bit of space science in grades 7, 8, and 9, we'll certainly have an easy way to hook our learners and get them interested in studying further. So over to Dan and his team.
Thank you very much, Pam. I have an entire slide in honor of your wisdom from June, Pam, and it may not have been very apparent, but we are big fans, particularly at the Earth Observation Division, which is the home of geographers. We have a very, very big respect for geography. We love geography and we embrace it in its mighty fullness. So we're going to dispel all the myths that we don't value the subject. So what I'm gonna do, I'm gonna share with you my screen, and hopefully you can see my presentation. Let's see. Can you see my presentation?
Yes, the whole presentation. I don't know if you can just put the slideshow.
Slideshow.
Awesome.
There we are.
Thank you.
Okay, so thank you for the opportunity. My name is Dan Matsapula. I'm a rural boy. I'm a boy from Limpopo who has found himself in the space industry 20 years ago at Stellenbosch University studying satellite engineering. And I tracked satellites for about 7 years for the Government Department of Communications, taking this data that I got from low Earth orbiting satellites at the Denel facility in the Overberg Test Range, Western Cape Province. And I would give it to the remote sensing guys, ladies who were doing remote sensing, image processing, analysis, applications development. I grew very curious and I said, what are they doing with this data that I'm giving them? I can't just be the guy who gets the data and never get to see the fun that they have from it. So my presentation will talk broadly about, and I'm with my team here, Johnny and Sinesipo. They will each have a chance to interact with you. Sinesipo in particular, because we want her to get used to talking to teachers, because she's used to talking to kids in schools. Now she gets to talk to their parents who are teaching them the vectors and the rasters. So my presentation will focus on this outline: space in South Africa, the introduction to SANSA, of course, and the home of geographers, the Earth Observation Program. My boss is a geographer. Using GIS in the unit for operational purposes. How SANSA supports the geography curriculum, and information, of course, about the tours of our facilities, the Hartbees Hoek facility that we've hosted several of you and your groups, and the Hermanus facility in the Western Cape. Without wasting time, space has a strategic importance in South Africa. We have more than 60 years of involvement in space. When the first man-made satellite was launched in 1957, South Africa was actively playing in this domain without a space agency, but through various other pre-existing organizations like the Council for Scientific and Industrial Research, like the National Research Foundation. Of course, they've since changed names throughout the years. But if you look at the 10-year innovation plan of the Department of Science and Innovation, 2008 to 2018, it's a 10-year innovation plan. It identifies space science and technology as one of the 5 grand challenges that South Africa identified as areas of strategic investment to help us migrate our economy from the resource-based model that it was at that time, and still largely is, towards a knowledge-based economy where we are not mining resources from underground, but we are mining the infinite resources of the human intellect. So, South Africa's involvement in space post-1994 was strongly motivated on socio-economic basis. We are not in space for space's sake. We are not in space to just be among those who are spacefaring nations. And we are a spacefaring nation now for 21 full years since the launch of the 64-kilogram satellite SANSAT by Stellenbosch University. And so you can see from this slide, in fact, you can see the entire connection between our reason for being in space and the geography that Pam talked about in the umbrella slide. Environmental management, health and safety, economic, socio-economic pillar. These are the pillars, and these departments on the left, from defense all the way to transport, they came together and identified their needs, and they were broadly classified into these 3 categories. Now let me introduce you to SANSA. SANSA was created to coordinate, to speak with one voice. South Africa had many voices speaking on space. You had departments that had elements of their operations and functions that needed to leverage space science and technology products and services. So we needed certainty, we needed one voice, and the SANSA Act number 36 of 2008 was signed into law by then acting President Kgalema Motlanthe. And that's how SANSA was created, leveraging the global nature of the space industry that South Africa had been playing in. We have been part of the landing of the man on the moon in 1969. So today, there's talk of return to the moon. Today, massive investments are being made in space to leverage it for socio-economic benefits that it promises for our society. As we rebuild our economy, we are on a massive economic recovery plan. This pandemic has put our economy back many years, and we need to utilize every strategic technology base that we have. So space is very strategic, and it is in that spirit that we are engaging with the geography educators today. And there are three main types of satellite orbits in outer space. Low Earth orbit, this is where I used to track satellites for the South African government down at Aniston near the coast. We have medium Earth orbit and geostationary orbit. South Africa has had more than 4 satellites, and these satellites have been launched into, all of them have been launched into low Earth orbit. So low Earth orbit is like the entry level into outer space. If you can't get to low Earth orbit, you can't go anywhere else, because the price continuously increases as you go further and further deeper into space. So we have capabilities today. You'll notice the first 2 satellites that were launched, one was built by Stellenbosch University. The second one was built by Stellenbosch University in collaboration with its spin-off company, SunSpace, which is no longer in existence as SunSpace. And of course, they were tested and assembled at the Assembly Integration and Test Facility in the Western Cape. That was part of the old South African space program. In Grabo, you will find the where I was trained in satellite engineering. And then you will start to notice a trend. By the way, Sansat weighed 64 kilograms, Sumandila Sat weighed 81 kilograms, and it was orbiting at an altitude of 500 kilometers, fitted with a powerful camera that takes images of the Earth that could resolve on the ground any 2 objects that are 6.25 meters apart. That is what we call its spatial resolution. And it has taken around 2,000 images during its lifetime, and its control was through the mission control that is at Sansa Space Operation. The lady by the name Gladys Magagula was the mission control specialist. She's from Mpumalanga, and we use her a lot to deal with the girl children and stimulate and inspire them to see that there is no such thing as a male-dominated industry. And this is another message we are sending to you teachers, to say, bring up those girls into this industry. We have a lot of dominance by the men. And as you can see, it's Johnny, Dan, and Sinesipo. So 66.6% of my team is male. Okay, and then there is a revolution that is taking place. We call it the CubeSat revolution. We are building satellites the size of a loaf of bread today. And the latest satellite to have gone up into space in 2018 is called ZA Cube 2. Its primary mission is to monitor our oceans, to provide us with intelligence over what is happening in our exclusive economic zone. So marine sciences that you've highlighted in the umbrella of geography, Pamela, is definitely covered for. We work with various stakeholders in government as part of Operations Pakisa. So this is our image acquisition coverage at SANSA. We start receiving, what it means is any satellite that is orbiting around the Earth, and as it crosses down the equator from about 5 degrees south of the equator, our antennas at satellite ground station, those that you see on the right, at Hartebees Hoek, are able to start communicating with it, receiving a signal from that satellite from around Bujumbura in Burundi there, all the way south, 50 degrees south into the oceans. So this is our coverage circle, and you can see that because of that, we are a strategic player in the Southern African development community, because we have sitting in our archives data of strategic value to our neighbors. So SANSA was created really, it's a government body, it's an agency of the South African government to promote and use space. we encourage cooperation in space-related activities, and we provide for an environment that is conducive for industrial development. That is why from geography teachers, we want you to help us to start inculcating an entrepreneurial mindset in our children, to help them see that there isn't just jobs that are possibilities upon their graduation, but that they can start creating value. And entrepreneurship, if you look on Google, is defined as the creation or extraction of value. And this value may not necessarily be of an economic nature. It can be of an economic or non-economic nature. So we are reporting through the SAGTA board to the Department of Science and Innovation. And you know, in the 6th administration of Mr. Cyril Ramaphosa, we now report under the Ministry of Higher Education, Science and Technology. And the Department of Science and Innovation is one of the departments within that ministry. So we are organized, and by the way, the science engagement program that I am managing is a cross-cutting activity across all of SANSA. You will find it in Hermanas at Space Science. You will find it in Hatibia's Hook at Space Operations. You will find it at Earth Observation, headed by myself. And the engineers are also coming to the party in terms of that, working with the engineering industry in South Africa to introduce our young people to microchips and subsystems development, and actually getting them from knowing but to doing now, touching things, feeling things, taking measurements, recording temperature, humidity, etc., etc. So these are the programs. The development of satellites remains the engineering programs forte. They don't just develop the satellites. They need the users' requirements. And we at the Earth Observation, if it's an Earth Observation mission, we are at the forefront of developing those user requirements in line with our response to the broad socio-economic mandate that got us to be in space in the first place. Space operations, we support launches of satellites through rockets from all over the world. That first slide I showed you, where we are connected to an entire ecosystem of other players, major players in the developed countries. This is how we leverage, and some of them we host their infrastructure on our premises because it boasts some very wonderful qualities, among which is that we have the most radio noise quiet environment in those mountain ranges of the Magaliesberg, where we are nestled in between. And we don't suffer from radio noise, and that is a strategic advantage for us. So we are a very attractive partner to many other space agencies, largely also because we are in the Southern Hemisphere, where you don't find a lot of these players playing. Space science, their laboratory is 150 million kilometers distance between the Earth and the Sun. They are using satellites that are dedicated to monitoring activity on the surface of the Sun, because that helps them with the mission of forecasting space weather and providing warnings to those industries that are susceptible to disruptions because of the sun's activity as it goes through an 11-year solar cycle, from solar minimum to solar maximum. So they work a lot with space physics. They work a lot with electromagnetic technologies. They do a lot of campus calibration for the South African Air Force. And increasingly, they are becoming very strategic to the entire aviation sector because, you know, pilots get exposed to radiation on particular flights. And these guys help pilots to include space weather forecasting as part of their flight planning so that they reduce the risk of increased radiation for the pilots who now have to be grounded until their radiation is within acceptable limits. So there's an entire science behind it. And the area in which they are in Hermanas is the most geomagnetically quiet environment, because for them to do those sensitive measurements, and they also have instruments down in Antarctica at the Sinai base of South Africa. So we have the teams going to Sinai from time to time, working with other partners, including the Department of Environmental Affairs. And then, of course, there is the Earth Observation Program, which is what I represent, and the majority of the slides would be dedicated to the Earth Observation Program, because this is the home of geographers. You will notice that there are two divisions that are missing, or so-called application areas. One is a telecommunications application area, and we are currently entertaining the idea of putting together the first telecommunication satellite of South Africa that is going into geostationary satellite orbit, some 36,000 kilometers away from the surface of the Earth, popularly known for providing direct-to-home television through such companies as MultiChoice and many others that are playing in that space. We are also looking at the global navigation satellite system, which is where we will be working on an augmentation system to improve the accuracy of the GPS signal in Southern Africa, so that our pilots can be able to land in zero visibility without necessarily having to be in control of the aircraft through the autopilot function, and that our farmers can start increasingly embracing on an operational level what we call precision farming, because it will be enabled by the higher quality of GPS signal in our area, and many other automated processes that will be possible, including precision fishing in our waters. So space is really permeating all areas of human endeavor. We have a new vision, which is to develop an integrated national space capability that responds to socio-economic challenges in Africa by 2030. You know that the National Development Plan is Vision 2030. You also know that on the global scale, the Sustainable Development Goals, it's also looking at 2030 as the planning horizon. Our mission is to provide leadership in unlocking the potential of space for the advancement and benefit of humanity. In fact, our motto is in service of humanity. This is why we provide science engagement as a public good to South African public, and we look to you, geography educators, as our partners, because when we work with you, we know that we are going to harvest the multiplier effect. One teacher teaches hundreds, if not thousands of children, and we look at schools as the entry level into our society. We are going on a massive paradigm shift, not just brought about by the global pandemic, but brought about by the strategic planning horizon, where we have said, we know we have been focusing on South Africa for the formative period of SANSA. And SANSA is turning 10 years old this year, because Minister Pandor launched SANSA in December of 2010, just after the World Cup. So in December, we will be turning 10 years old. So we are broadening our focus towards the continent of Africa. I know you may have heard about a very powerful planning document, planning horizon called Agenda 2063, the Africa we want, with Africa being the youngest continent in the world. 1.3 billion population, and the youngest population in the world means that we finally have a window of opportunity like we do when we have a launch window in the space industry, during which we must play our cards right. Quality education is my favorite sustainable development goal, number 4. We need to educate our young people and get them ready to be meaningful players in this emerging knowledge economy, where we are mining the infinite resources of the human intellect. Now let me tell you a little bit about the home of the geographers, the Earth Observation Program headed by Ms. Andy Swamlisa from University of Fort Hare, University of Stellenbosch, hailing all the way from the Eastern Cape province with a very good record of traveling around the world, getting exposure into the trends in the world of Earth observation. So We are arranged around 4 units, and you are talking now to the science engagement unit that I heard. There is the research and applications development unit. These are the guys who develop applications from satellite imagery that we have in our archives. And increasingly, they are working with a cloud-based infrastructure to be able to take away the requirement on the user side to be working with heavy storage and processing facilities. You just access your data from the cloud. We have the data systems management that are really the infrastructure management team. They are the interface between the space operations facility in Hartebeespoort that directly receive the satellite telemetry and get the data archived in our data sets. Petabytes and petabytes of data. This is what the data systems management team is looking after. And then, of course, we are looking at the SAGTA and business development unit that deals with the development of the sector from the SANSA mandate, create a conducive environment for industrial development. That is directly from the SANSA Act of 2008. Now, Earth observation, of course, it's about using not just satellites in outer space, but also ground-based sensors, including those in situ sensors in our oceans, like buoys, like those weather stations, like a lot of many other instruments that are even on board aircraft. So all of it is incorporated into the Earth observation domain, and the combination of these give us the full picture. Satellites have a unique advantage in that they are able to cover large area without being in close proximity or direct contact with the area, orbiting at hundreds of kilometers above. So our information that we generate is intended to support decision-making, policy development, and of course, unlocking massive socioeconomic benefits in government and in society. So for your classroom, remote sensing is the science of obtaining information without being in direct contact with the area from which you are deriving that information. So we link it very much with the 5 human senses, 60% of which can sense remotely. And we use this to help our young people to understand that we do remote sensing every single day. It's just that with our eyes, our remote sensing is limited to the visible part of the frequency spectrum, 400 nanometers to 700 nanometers. But satellites in outer space can operate in other frequency bands in the electromagnetic frequency spectrum. So we are transforming terabytes and terabytes of Earth observation data into information. Today, WhatsApp, Facebook, many of people check in at the airport on their flights to wherever, and WhatsApp your location. This is all geospatial information that is enabled by this GIS remote sensing Earth observation field. So this is the value chain. We developed this poster, by the way, and you will excuse the D in the definition of remote sensing there. It says "and" instead of "an object." The sun being the major player, the Earth receiving lots of radiation and reflecting some. So passive sensors, those that depend upon the sun's illumination, for them to characterize the phenomena that the reflected solar radiation has interacted with on the surface of the Earth, like Sumbandila. All of South Africa's satellites were carrying passive sensors on board. We also have active sensors that can independently generate their own illumination, send it down, and receive reflected radiation. And those are very particularly advantageous for those rainy days. They can penetrate through cloud, and they can work in total darkness. So we are increasingly looking at broadening our sensor portfolio to incorporate both the active and the passive sensors. And of course, all of this data is intended for the applications to support the farmer, environmental manager, the ESCOM people who are monitoring their transmission lines so that nobody builds underneath them, because the cost of removing people who have built underneath is very expensive. So they must decide, do they spend the money removing the people, or do they proactively monitor their infrastructure and at a much lower cost to cut out the need to pay those expensive and maybe even court cases. So GIS, it's our favorite. Sinesipo is going to take you a little bit on how she's our resident geographer. So we use actively, as we have a national mandate, to put space awareness in every classroom and to help those target audiences that are identified in the science engagement strategy that is cabinet approved, to bring about a culture of innovation and research in our society. And this is where we come into your classroom and we say, we support you, and we are grateful that curriculum has definitely adopted GIS and remote sensing in grade 10 to 12 geography. And Pam, we look forward to working with you before it's even made official in bringing space into the classroom. For goodness sake, there are so many lessons you can develop from space science and technology, from satellite simulation software, and you will see just shortly the kind of hands-on activities that we talk about, and Sinesipo will talk to that. And let's get our children doing things. It is not enough to know the definition of remote sensing, the science of obtaining information about the phenomenon or location without being in direct contact, using instrument-based techniques. That is fantastic to know the definition. However, it is in the doing that the reinforcement of the understanding. So here, it's change detection in the human settlements application area. That is not just useful for the community that is affected. Here it's Limpopo. It's not just for the Limpopo government planning. ESCOM needs this data. Municipal Demarcation Board needs this data. Everybody who is involved in some element, schools need this data, because as they settle there, they need education, they need electrification, we need to make sure that that area is safe. It's an inhabitable area. And so as human settlements are growing, the population increases, it has implication to the economy. So we need you to be on board with us to get these children to touch things, to do things, to become relevant in their communities. As I said, schools are an entry level into the communities that these children come from. And we need to increasingly use them to effect meaningful change. How susceptible is the school premises, are the school premises to disaster management? How susceptible are they? So we work a lot with various provincial departments that deal with disaster management, and they have school campaigns. And this is where we need you as geographers to come to the party to say, what you are talking about is what we are teaching in class, and those extramural activities, they reinforce your classroom activities, including the visits to our facilities. So flood risk mapping, these are just some of the activities, and we do this up to the local scale. This is at national scale, risks and vulnerabilities. And you know that we are currently going through a massive disaster that is called the global pandemic. In response to the mandate, the socio-economic mandate, here is the Earth observation community. And you can see that virtually every part of your livelihood is impacted by Earth observation. These are our key users. And these are not the only ones, but this is government and its agencies, the banks, insurance companies that may not even feature there. Even the square kilometer array, the astronomers, I was interacting with them and they were showing me how they were using GIS for site identification. Remember, for them, RFI, radio frequency interference, it's something they don't want to hear about. So they go to great lengths to make sure that it doesn't feature even by chance. And even the transmission of electricity to their facilities in the Karieberg local municipality in the Northern Cape. They don't use normal ESCOM transmission lines because those introduce a particular magnetic noise and electrical noise into their system. If you visit those facilities, and I have had the privilege of doing so, your car, you will not get to within 30 kilometers of the actual site. Their cars only are allowed because the spark plugs in your cars are some of the sources of interference that will interfere with their sensitive measurements that may be coming from millions, if not billions of kilometers away. So GIS is widely used. And I'm gonna leave it here for young Sinesipo to tell us how she is using GIS in the unit, because we have a national mandate. Last year alone, we engaged with over 25,000 young people during the 2019-2020 financial year. The best year ever since I took over this unit. So Sinesipo, feel free, let me stop sharing. Oh, I won't stop sharing. She's gonna
please don't stop sharing.
Yes, she's gonna need the same presentation. Should I play them from this side, Sine?
Yes, please.
All right.
Okay, so my name is Sinesipo Ngamile, and I am the Science Engagement Intern at SANSA. So as Mr. Matsapula has already said, we are in the Science Engagement Unit or the Science Engagement Program, and we are involved in SANSA, or we support one of SANSA's goals, which is strategic goal number 4, which is the development of requisite human capacity that is needed for the implementation of key space initiatives. So geography educators also form part of this human capacity or human capital development. And yeah, hence we have this presentation today. Geography as a science, as Mr. Matsapula has already said before, geography is a science. So it involves agricultural science, atmospheric science, environmental science, earth science, geospatial science, social science, economic science, etc. Please, yeah, thank you. So what we do in the Science Engagement Unit is we stimulate thinking through science engagement. We support STEM education or science, technology, engineering, or mathematics education for the knowledge economy. We promote the innovative use of space science and technology by the youth, and we develop awareness of career opportunities in space science and technology. So these are our target publics, and if you see there, as you can see, we do have educators as part of our target public. So we have to make sure that we reach all of our target publics, and educators are also part of this. But most of the time we focus on learners, students, and the general public. But we do engage with educators at other times. So, Mr. Matsapula, can you please
this one? Let me just briefly. Yes. Oh, so this is the science clubs. Sorry, it doesn't appear very clearly up there. I think somehow the slide got cut. What we are encouraging, particularly from this touching, feeling, doing, getting involved, taking GPS measurements and measuring the perimeter of the schoolyard, area of the schoolyard. We establish science clubs at schools, and we work with existing science clubs. So geography is part of the science clubs because it is a science. So we want them to use geography activities, understand GPS coordinates, X and Y, latitude and longitude. So that is just that slide, Sine. Continue.
All right, thank you. So SANSA's Science Engagement Program implements the science engagement strategy of the Department of Science and Innovation through its Science Engagement Unit, which develops and implements the National Space Awareness Program. So the Department of Science and Innovation's Science Engagement Strategy It intends to develop a society that is informed about science, a society that is critically engaged, and a society that is scientifically literate. And the science engagement contributes also to SANSA's strategy goal number 3, which is to develop a national human capacity and to ensure transformation in our country. So our platforms are, okay, so the science engagement unit, it uses the wow factor of outer space exploration to stimulate youth interest in science, technology, engineering, and mathematics. So we use 2 mass participation programs, that is science festivals nationwide. So science festivals nationwide. So we go all over the country and we attend science festivals, and also National Science Week. I don't know if the geography educators know more about National Science Week. Also, we have other uniquely SANSA platforms, which include guided group tours of SANSA facilities, which we'll explain more about towards the end of the presentation. We also have direct school visits. We go to schools directly, leveraging SANSA networks, training science center staff in space science and technology, public engagement through the media, profiling careers in space science and technology, and we support the curriculum that is also geography, which is aligned to SANSA activities. Oh, there's an example there: geography, GIS and remote sensing, and planet Earth and beyond. So in our unit, we also use GIS, or Geographic Information System. We use GIS for monitoring and evaluation systems because they play a fundamental role in collecting, in storing, and tracking the performance of the science engagement unit nationwide. So we also use GIS for planning purposes, for reporting, and to monitor the national impact of SANSA, since we attend science festivals all around the country, all over the country, I mean. So using GIS software for planning purposes. So this is an example. It is something that I created back in February. So there was an event that we were invited in. We went to a science festival at Taung in the Northwest Province, in the Greater Taung local municipality, which is part of the Dr. Ruth Sehomotsi Mompati district municipality. So we used GIS for our planning to see the distribution of the schools or location of the schools, so that we could engage with them. So this also helped us with seeing how far the schools are from all the various venues we would be engaging with them in. And this, okay, as mentioned before, we also use GIS for reporting. So this basically shows our national reach. We reached 36 districts out of the 52 districts in our country in the 2019 and 2020 financial year. And the red dots there are all the schools that we reached, all the science centers that we reached, basically all our target publics. So using GIS, I was able to show like a distribution or illustrate an image of how we traveled all around the country, and we managed to reach our targets, and we managed to reach our targets basically. And this is also, okay, this is just another image which shows the names of the districts that we reached. And like I mentioned before, we reached 36 out of 52 districts in the country. So we basically reached all provinces, but not all the districts in the provinces. And so to do all this, I used open source GIS software. So there are various types of free and open source software or FOSS, which can be used for implementation, monitoring, and reporting. So SANSA's Science Engagement Unit utilizes some of these open source software, such as Google Earth. I'm sure most people know about Google Earth, and QGIS, which is also called Quantum GIS. So our unit also makes use of Google Maps, which is also available on your cell phones. But for reporting purposes and for planning purposes, we use Google Earth and QGIS. GIS. And also I have to mention that I do have a manual on how to download these softwares and how to use them. So if anyone would like a copy, I would be happy to send it to you so that you can see how to use GIS software, which is free, basically. So you don't need any license to use QGIS or Google Earth. So how do we get the data we use for GIS? As you saw from the images, from the previous images of the maps, we have province data, we have district data, and also municipality data, which can be downloaded from the municipal boundary board. So you can search for it on Google, and you will be able to download province data or country data or even municipality data, which you can use. And the manual also shows you how you can download all this information from the internet as well. So using GIS and remote sensing in the classroom, how SANSA supports the geography curriculum. So I was also a geography student myself. I finished matric in 2014. So I used to love geography a lot. Hence, I decided to create all of these examples that you'll be seeing now. I used my school as an example, Cathcart High School, which is a school in a small town in the Eastern Cape in Cathcart. So this is one of the softwares which basically show how satellites are orbiting around the Earth, and it just basically shows see that blue
circle.
Yeah, the blue circle there. It basically shows the cover. I think Mr. Matsapula explained in the previous in his previous presentations about the coverage of our satellites in South Africa. So this basically shows that. And okay, so for curriculum support, so this is basically an image which was taken from Google Earth, and which it shows how you can calculate areas, the area of your school using the Google Earth application. And as you can see there, it also shows the coordinates. I know that currently geography students are learning about lines of latitude or lines of longitude. So this could basically show them a more practical example of how coordinates are used, or how latitude lines and lines of longitude are used in Google Earth. Okay, so I thought this would be a fun example to show students in the classroom how they can use, or how they may use satellites every day. So as you can see, these images are taken from a cell phone. So I just took a screenshot of my school in the Eastern Cape, which is Cathcart High School. So the first image basically shows how low Earth orbit satellites are used. So low Earth orbit satellites use images. So I just screenshot an image of my school. So you can explain to the learners that they can use their cell phones to see how low Earth orbit satellites are used every day of their lives. And then there is the second image, which shows medium Earth orbit satellites. Medium Earth orbit satellites are used for GPS or navigation. So I just tried to show you an example of how I would navigate from Pretoria to my school in the Eastern Cape. So yeah. And then the third one is basically shows an example of geostationary Earth orbiting satellites. They are used for the internet. So Google would be a very familiar example to show the learners in the classroom. Okay, so the next image, it also basically shows how you can use Google Earth to give examples about lines of latitude or lines of longitude. So learners may be able to get, I wasn't done explaining. Thank you. So learners may be able to get and use the coordinates of their schools. They are also known, these coordinates are also known as geographic addresses of features. They can use the address to map their schools, to map their homes or places that they have been to using GIS software. So I don't know if your schools have computer labs where you can take the learners and show them, download Google Earth Pro and show them how they can use lines of latitude and lines of longitude. Because I remember in my school, we never had examples of how we can use Google Earth or how we can use our cell phones to show lines of latitude or lines of longitude. It was almost all theory. We never had any practical work to show us and help us understand all of this. Okay, so the next example. So as I mentioned before, I used an example of my school in the Eastern Cape. As you can see again, Catholic High School is there. So again, if you have computer labs in your school, you can show learners how to use QGIS or Quantum GIS, which is a free software. So learners in the classroom can understand more about vector data. So I know vector data, we started learning about it from grade 10. But we never really understood what it's about. Yeah, we knew about lines. We knew that it has to do with points. We knew that it has to do with polygons, but there was no practical example again. So learners in the classroom can understand more about vector data by trying to map their school or their homes using QGIS. They will be able to see an actual representation of a point being a building of their school. A point is a building. A line being a line segment which surrounds the boundary of the province or district, or a polygon being the province, the area of the province or the area of the school grounds. Okay, as I mentioned, an example used here is Catholic High School. Yeah. Okay, and then the next one basically shows how learners can calculate area, the area of their school, or the hectares in their schools, or the perimeter of their schools using QGIS, using Google Earth. Again, there is an example of this. There is more of an explanation of this in the manual that I did, which I hope you guys will be asking me for so that I can send it to you. And this also shows how you can use Google Earth for practical work in your classrooms, calculating the perimeter of the schools or calculating the area of your schools. Next one. Okay, so this is an example of how you can explain raster data. So raster data refers to the digital area of photographs or imagery from satellites, digital pictures, or even scanned maps. So it is also part of remote sensing because it includes the use of satellite imagery to obtain information from different Earth features without being in physical contact with any of the features. So basically in the classroom, you just show them an image of their school, and then you try to ask them if they can identify a building or if they can identify a part of their town. So that would be another activity which you can do, which is related to GIS, which will also help them understand more about how to use GIS or how GIS is used. Okay, so another activity would be change detection using satellite imagery. Again, you use Google Earth, and it is also part of raster data. So with change detection, as you can see, there's around an oval shape there. And then this is cut in 2010. And then in the next image, it's cut in 2020. So using this image, using images from Google Earth, they will be able to see how change detection works, and you will be, they'll be able to identify how areas have changed over time or how the areas surrounding their schools have changed over time. Even usually when we go to other schools in rural areas in the different provinces that we've been to, we usually, sometimes you find that a school has just been recently built in 2015 or 2016, and we show them an image of their school maybe in 2002, and there was no school there at all. So when they see an image of their school in 2016, they get surprised about how things have changed over time and all that. So using Google Earth this is another activity which you can do in the classroom. Show them the areas of different areas and show them how change detection works in GIS. Okay, so this is another way of including GIS in your curriculum. This is the Fundisa Disc. The Fundisa Disc is an initiative which has started in 2009 to provide students with an overview and a gateway to remote sensing. So Fundisa means to teach in isiZulu, and it is an appropriate way of describing the functionality of this geospatial tool. SANSA's Fundisa Disc is made up of Earth observation data, such as satellite imagery, a variety of vector data, open source software, and sample imagery. So if you are requesting a Fundisa Disc, you basically have to you contact SANSA, and we make a plan to get it to the schools or to any universities that may need it.
And it's even available virtually. Johnny just delivered a couple of them during lockdown.
Yes. So you can contact us and yeah, we'll be able to provide it to you. And then the visits to SANSA facilities. So we do have learners or students who come to our facilities. We have university students or high school students or even primary school learners who come to our facilities. So any schools wishing to visit our SANSA facilities can contact our Science Engagement Unit or contact our SANSA head office using the following email address, which is provided there. SANSA tours can be booked only for Thursdays, but there are currently no visits allowed due to COVID-19. So those are basically images of those are basically images of learners who are, okay, the first one is learners who were listening to a presentation that we were giving. And the second image is basically students who took a picture in front of the many antennas one of the many antennas that we have on the facility. So it would be nice for the learners to be able to see and get more of an explanation of how antennas work and how antennas communicate with the satellites in space. Yeah. And then we also have our other facility in Hermanus in the Western Cape. Also, if you want to visit the facility in Hermanus, you need to contact our SANSA head office or contact one of our science engagement units. As Mr. Matsapula explained earlier, the science engagement unit is a cross-cutting program. So we have science engagement in Hermanus and all our other directorates at SANSA.
And they have a science center in Hermanus as well.
Yes.
So this brings us to the end of our presentation, ladies and gentlemen. Thank you for your attention and time. Any questions?
There are questions on the...
Can you hear me? Sinasipo?
Yes, I can hear you.
I just want to say thank you for this informative session. You inspired us to take the kids to a next level of technology, to learn better, and to experience the new life coming their way. I definitely would like to make use of this opportunity to deal more with you and to expose the kids more to this environment. I'm so proud of you. It's my old students sitting, talking there.
Yes, he was my geography
Listen to you teaching me, actually. Teaching me.
Wow.
So, thank you. Thank you very much. I appreciate it.
Thank you, Mr. Theron.
Oh, that's awesome. I love that. Thank you.
Thank you.
There were a few questions that were put on the chat, but we've gone kind of over time already. So I don't know if you can answer them like in 2 minutes quickly, because I know people don't have indefinite data. If we can start at the top there, do we have any current South African satellites orbiting and working? How many do we have at the moment?
Currently, 2 of them are working that are government funded. There are also private sector satellites that are part of global CubeSat missions.
Okay, great. Stembele would like to know Are there any satellites orbiting that we're not aware of? And if yes, what is the strategic purpose of their existence and why don't we know about them?
There are around 4,900 satellites orbiting around the Earth globally. So some of them are civilian satellites, some of them are military satellites. So military satellites generally are high secret, top secret satellites that you won't know about. They are classified.
Okay, thank you. The next question is there a retrieval procedure of decommissioned satellites because of space debris?
Normally, the requirement when you develop a satellite prior to you launching it, you are required to provide enough fuel on board such that when it runs out, when it's coming to the end of its mission life cycle, then you can push it out into a graveyard orbit or into an orbit where it is not interfering with existing operational satellites. It's like the scrapyard of outer space.
Wow, that's fascinating. Okay, how can geography teachers access those beautiful Earth observation images that you were showing us?
A lot of them are in the public domain, but if they are not, like platforms like Google Earth have got a lot of satellite images, but of course, rural areas have less coverage than urban areas. If you need more information, data, you are able to order data from SANSA. Depending on the regulations regarding the particular sensor, if it's in open and it's free, like the China-Brazil Earth Resources satellites, then we are able to make it available for free. But if it is one that we pay a license for, then it has got cost implications. But there is a lot of free data today doing the rounds. In fact, we are the champions of data democracy for developing countries.
Awesome, thank you. Do you have career pamphlets or posters for schools?
Lots and lots and lots of careers. In fact, we are currently updating the 2014 edition of Careers in Space Science and Technology. And we want to bring diversity because many of the people that are profiled there are employees. And what we are unconsciously sending as a message is that this is a field you can only work as an employee. We want to bring the entrepreneurial flavor and profile South African space entrepreneurs, including guys like Elon Musk that are not even here anymore, to say that young people need to increasingly entertain innovation and entrepreneurship as options for their exit points at graduation.
Thank you so much. So they can contact you or any of your team?
Any one of us, yes. We will reroute the requests.
That was fascinating, absolutely brilliant. And we kept seeing pictures and then Pam would make a message, that looks like a poster for the geography classroom. So thank you. It was so relevant to all of us. Are there any more comments from anyone?
Thank you very much.
Thank you.
Thank you. That was awesome.
I feel so empowered. Yeah.
Yes.
Paul, thank you very much for a lovely presentation. Dan, thank you for your input. Johnny, you were very quiet, but really I think you've brought another dimension. You've given us a lot more to think about when promoting our subject. And I think something we've really got to start doing is working side by side with SANSA. So thank you very much for everything you've done for us in this webinar.
Thank you very much, Pam.
Thank you very much, Pam.
Okay.
Right, have a lovely day. Goodbye, everyone.
Guys, before we close, we will inform the SAGTA group as soon as tours are allowed. We'll send an email out saying that groups are welcome. So, watch the space.
Awesome. Thank you so much.
Thank you, Johnny.
Thank you.
Right. Bye, everyone.
Bye.
Love you all.